Alright, so what we want to do now is we want to take what we just learned about the summary of horizontal and vertical translations, and we're going to put it to use. And we're going to say, you know, if I have this equation, what's it going to look like? Alright, so remember that the number out here, this is the one that tells me up and down. Okay, and then the number that's inside of the absolute value, that one tells me the left and the right translation. So the one on the outside is pretty easy. Whatever it says is what you do. Here it says -3. Well, is that going to be an up 3 or a down 3? That's a down 3. Okay. The one inside of the absolute value bars is a little different and can be a little tricky. It says a +2, which normally means to the right if you think about a number line. However, you have to think about where did this come from. If we remember, that's the form of the equation that we're talking about. So in order to get a +2 there, you would have had to put a -2 in. So whatever's inside of here, you have to take the opposite of. Just like when you were pulling out your vertex on the graphing part, you had to take whatever was opposite of in here. That's very important, and you're gonna continue to see this in multiple different kinds of graphing in this classroom. So the +2 really means a -2, so that means to the left 2. Okay, so I went down 3, left 2. Alright, let's look at this one. If you notice, my 2 is inside of my absolute value bars. But remember that you could pull that out, just like factoring. So let's do that. Okay, so now my 2 is out in front of the absolute value bars. So first off, this +4 outside of the absolute value bars, just like here. So is it going to be an up or a down translation? Well, it's a +4, so this is up 4. Now we're going to look at this 2. Remember that a number multiplied on the outside either means it's going to be narrow or wide. Now, is a value greater than 1 going to be narrow or wide? And a value of 2 means it's going to be narrow. Think about slope. That means you're rising 2, running 1. So you're rising faster than you're running. So this is going to be narrow. Okay? Alright. So next, let's say we start out with our parent function, the absolute value of x. And I want to know what is the new graph, or the new equation, after going 2 up and 4 to the right. Okay, so I've got to take this equation, go 2 up, 4 to the right. Alright, right now, this parent equation, your vertex is at 0, 0. So if I'm going 2 up and 4 to the right, that means I'm going 4 on the x, 2 on the y. My new vertex is 4, 2. And I could take that and I could put it into this equation. So this would be y equals the absolute value of x. And remember that it's minus because it was originally a positive, so -4 and +2. Your h and your k are your vertex. Alright, if you weren't comfortable with doing this, you could have said, alright, 2 up. I know that that's going to be a simple adding 2 at the end of my equation. Okay? And 4 to the right, well, I know when I take it out of the equation, I have to go opposite. So right really means a negative, so -4. Okay, and you could have came up with the same equation that way. Alright, now let's say we have y equals the absolute value of x -4. And you want to know what's the equation after it has been translated 5 units to the left. Okay, so currently my vertex is 4, 0. Remember, take the opposite of what's in there, so 4, 0. If I'm going 5 to the left, that means I am subtracting 5. Okay, because right now your graph, here you are, 1, 2, 3, 4, at 4, 0. You want to go 5 to the left, which means you're going 1, 2, 3, 4, 5. So you're subtracting 5, which means you end up with -1, 0. Okay, now I'm just going to take that and I'm going to put it back into my equation. So y equals the absolute value of x plus 1, because this is a minus 1, and then plus 0, so you don't need to write the plus 0. Alright, now what we're going to do is we're going to take some equations. We are going to identify the vertex, and then we're going to graph them. And I'm just going to do some quick graphing. You can do some better graphing there. I'm just going to do kind of a quick sketch. Alright, so we've got y equals the absolute value x minus 3 plus 1. Alright, first off, where's my vertex? It's at 3, 1. Okay? What is my a, my slope? Remember, that's the number that's out front. So that's a 1. Alright, now we're going to graph it. So, that means I'm going to 3, 1. 1, 2, 3, 1. And my slope is up 1 over 1, so it's going to be the regular graph of the v. And that would be my absolute value function. Now, if I asked you what was the translation from the parent graph, you would tell me, well, I went right 3, up 1. Okay, so this one was right 3, up 1. Okay. The next one, y equals the absolute value x plus 4 minus 3. Alright. First off, identify my vertex. The vertex here is -4, -3. And my a value, or my slope, is a 1. If I look on that, the graph, I've got -4, -3. There's my vertex. And it tells me I'm still just going up 1 over 1, so it's the same normal V shape. And there's my absolute value graph. If I asked you what the translation had been, you would tell me left 4, because remember, going opposite of what this says, and then down 3. Okay? Alright, here's my next one. Negative absolute value of x plus 5 minus 3. Alright, identifying my vertex. -5, because opposite of what's in here, -3. What is my a value here? It's not just a 1, because there's a negative, it's a -1. Remember, what does this negative tell you? Look back at your summary table, and it tells you that the graph is going to be flipped down, so you're going to have that upside down v this time. Alright, so -5, -3. And instead of going up 1 over 1, I'm going to go down 1 over 1. So I'm going to have a graph that is pointing down. If somebody asked me what were the translations, you would have to say you flipped it or you turned it upside down. very important. That is one of the part of the translations. Here I went left 5, and here I went down 3. Okay? Alright, so let's incorporate a little domain and range. It's good practice. Let's say I've got y equals the absolute value x plus 3. First off, let's graph it. I'm going to identify my vertex. My vertex is -3 and 0. So -1, 2, 3, and 0. My a value is 1 because there's no number out there. Alright, so my graph's going to look like this. Alright. Now remember that the domain is all of your x values. That means your left to right values. So domain, I'm going to go along here, and I'm going to start on the left side, and I automatically hit an arrow. That means it's negative infinity. And if I keep going all the way to the right side, I hit another arrow, and that means positive infinity. Okay. My range goes bottom to top. So if I start at the bottom, I don't have any graph down here. The first time I hit a graph is right here, and this is 0 on your y-axis. And then it goes up, and I hit arrows as the last thing, so to infinity. Okay, you're going to start seeing a pattern here in a minute. The domain on every single absolute value equation is always going to be negative infinity to infinity, because you've got the arrows going out in both directions. All these x values are always being covered. Okay, it's your range that's going to change. It's just going to change upon how far up or how far down does the graph start. Alright, next one. Y equals negative absolute value of x minus 5. Alright, let's start out with my vertex. Alright, inside of there's a 0, and the outside's a negative 5. So that's 1, 2, 3, 4, 5, 0, negative 5 right there. My a value is negative 1, which means flip it upside down. Okay, domain and range. Alright, domain left to right. If I start at the left, the first thing I hit is an arrow, which means negative infinity. Going all the way to another arrow, positive infinity. Okay, now let's do my range. Remember, bottom to top for range. So the first thing I hit on the bottom is arrows, which means the range is starting out at negative infinity, starting down here in the negative. And when I go up, the last thing I hit is a negative 5. So that's where it ends. There's nothing above that. So negative 5. Okay. Alright, next one. Y equals the absolute value x minus 2 minus 6. Alright, so first off, my vertex, 2 and negative 6. So 2, 1, 2, 3, 4, 6, negative 6. Alright, the slope is just a regular 1, which means I'm going to have my regular B shape. Alright, I need my domain and range. Remember, domain, left to right. First thing I hit is that arrow, so negative infinity. Last thing I hit is an arrow, so positive infinity. Remember, that's just traveling along this x-axis. Alright, range. That's going from bottom to top. So if I travel along the y-axis, the first thing I hit is at negative 6. The last thing I hit are arrows, which means infinity. one more example. Alright, y equals negative absolute value of 2x plus 4 plus 3. Alright, if you notice that 2 is inside the absolute value, so I gotta pull it out. Remember, it's kind of just like factoring. So I'm gonna pull out that 2. Okay, so here's my 2. When I pull out a 2 from 2x, I get left with x. When I pull out a 2 from my positive 4, I get left with positive 2. Okay? Alright, so I've got my vertex, negative 2, positive 3. And what is my slope? Well, there's a negative 2. Alright, I've got just about every translation here that I could have. First off, I'm flipping it. Next, I'm making it narrow because it's a value greater than 1. Next, I'm going left 2, and I'm going up 3. So we've got every kind of translation here. Alright, so graphing my vertex, negative 2, positive 3. Alright, I'm going down 2 over 1, because it's a negative 2. So down 2 over 1. So I can see it's narrow. Alright, let's talk about my domain and my range. Alright, when I put left to right, first thing I hit again is an arrow. The last thing I hit again is another arrow. Remember, I said your domain on an absolute value will not change because it's the same shape. You're always going arrow to arrow. So negative infinity to positive infinity. Alright, your range, bottom to top. First thing I hit are arrows. So negative infinity. The last thing I hit is 3. Okay, so in terms of domain and range, it's not affected by the slope or that value that makes it narrow or wide. The only thing that's going to change is the range, and that depends upon where my vertex is going to be. Alright, that's it for the absolute value translations. The next one is going to be on two variable and